Rightio, let's have a look. We've got our learning intention is to be able to use Pythagoras' theorem to find the shorter side in a right-angled triangle. So here's our right-angled triangle over here. This time we've got our short side. There's our hypotenuse, our short side here. So we know Pythagoras' theorem is c squared, the hypotenuse, equals a squared plus b squared. Now a is what we want to find, but before we do this, I'm going to rearrange this and I'm going to write this a squared plus b squared equals c squared. Now that is exactly the same as that. Doesn't really matter which way we write it. So now why I've done that is because I want the a to be by itself. So we're trying to find the a. So I'm going to take this b over to that side. So if I do that, take the b over to this side, I get a squared equal to c squared take away b squared. It was a plus on this side. When I take it to the other side, it becomes a negative. So now we've got that, we can start thinking about our numbers. So I know my a squared is, I don't know. So now I'm going to put in my c squared, which is 21.5 squared, and I'm going to take away the b squared, which is 12.9 squared. Okay, so that's my a squared. So my a squared is going to equal 21.5 squared. I've worked that out before. It's 462.25. Take away 166.41. So I've put them in the calculator. Now I get a squared. My calculator. I take those away and I end up with 295.84. Now don't round it off until we get right to the very end. So I've got that. Now that's an a squared. So now it's going to change to an a. And how I do that, I've got to put my square root in. So the square root of 295.84, and my a becomes 17.2. So I just do a quick double check. I think about this. If this number ends up bigger than that, then I've done something wrong, because remember, this is a shorter side. We're trying to find the shorter side. Okay, so things to look out for. You're setting out. Okay, I've changed that over to there. Taking the plus b over to this side becomes a negative b. Put my values in, done my working out, I get that. Now I've left one thing off, which is, just realised, this is all in centimetres, so I must put centimetres on there. Now I've finished it. Okay. Rightio, so we've got Pythagoras' theorem here, which is c squared equals a squared plus b squared. I'm after the short side, so I'm going to rearrange this and I'm going to get my a by itself. Remember, I'm taking that b over to this side, so I get a squared equals c squared take away b squared. Now, I'm going to do e, okay? So let's have a look. I've got e. So now I've got my a squared equals c squared, my hypotenuse, take away b squared, one of the other shorter sides. My c, what's my c? My c, there's my right angle, so it goes straight across. It's 85. So it's going to be 85 squared, take away b squared, which is 51 squared. That was my b there. Now, once I've got that, let's start putting it in a calculator, and I get 7225, take away 2601. Now I've got to take those away and I get 4624 in my calculator. Now all of these is still a squared. Now I want the a. If I want the a, I've got to take the square root of 4624. When I do that, my answer becomes 68. Now, what am I missing? All of these are in centimetres, so I need to put my centimetres on the end. So, keep looking at those. You should get some nice whole numbers, hopefully, on the ends of those. Sorry, maybe not, because you've got that one over that one over here with decimal points. Okay, there you go. Rightio, let's have a look at question 2. The only difference here is we've got to leave it in exact form and highlight that one, and then also find out what it is into one decimal place. So I've written this up here again, but basically let's start with this one. So I know that a squared equals c squared minus b squared. Now, which question will I choose to do? I'm going to choose D this time, so it's just ahead of us. Now, it hasn't got any letter there, so what I'm going to do is I'm going to write an A on there. So now, there's my A squared, my C, here's my hypotenuse, because there's my right angle triangle straight across. So I've got 18 squared, take away 14 squared, put that into my trusty calculator, and I get 324, take away 196, and once I work that out in my calculator, we get 520. So this is my A, this is my A squared. Now, what I can do, I can cut down a step by just going A and putting my square root in there. So I've missed out one step in there. Now I get that. If I put that into my calculator and try to do anything in your calculator, you should get the answer of 2130. So what we've got, that is our exact value, and that is their exact values. This is the more mathematical way of writing it, but this way is fine. Okay? Now, we need to get, so that's the answer to part 1, or part 1, so either of those answers are correct. Now we need to find out what it is as an approximate value. So what that means is we just put it into our calculator. Oops, still in red, that's all right, and it works out to be 22.8. So that is part 2. So that's our approximate answer. So it's basically doing exactly the same thing, but recognising that this one here is our exact value, which can be simplified down to this, and we'll talk about that a little bit later. But this is the main one. If you can get to this one, fantastic. And then this is our approximate answer. I won't go into any more because they're all quite similar. Okay, there you go on that one. Okay, so this one is recognising our Pythagorean triples, or a multiple of a triple. So I've written down here, these are our key Pythagorean triples: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Okay, let's have a look. If I have a look at this one, I can do Pythagoras' theorem to work all this out and do the working out, or I can look over here. Does any of those match? Well, look, I've got a 13 and a 12. 13 and a 12. So that means that that side there must be 5. Let's go back. Let's have a look at this one. 7, 24. Whoops, 7, 24. What must that one be? 25. So the idea of Pythagorean triples is a shortcut way of doing these without doing any working out. It becomes quite important in Year 12, in Year 11 and 12. Just helps to recognise this one here is 26 and 10. So if I think about that, there's no 26s and 10s here, but let's think about this one. If this is 5 and 13, 2 times 5 is 10, 2 times 13 is 26. So this one here, if that's 2 times that, 2 times that, 2 times that, it must be 2 times that, which is 2 times 12 is 24. So I'll see if you guys can have a crack at those ones, but try and use these ones here to remember, and should be able to work those out. Okay, that's it from me.